So we've taken a look at types of tiles that can be used, and if multiple types of tiles are used together, okay, there will be more than one term in a polynomial. Okay. Each type of tile refers to a single term, and once each term is determined, then we add the terms together. Okay, so once we've determined each term, we then put them all together and we add them together. Now, when I say add them together, that doesn't mean we put a plus sign in between them all, and I'll show you that in just a little bit. Depends if they're positive or negative, but we add all of our terms together. So let's create a polynomial which is described by each set of algebra tiles. This set right here, you'll notice, has three different types. We have these large ones, these narrow ones, and these small ones. We have three different types, and each one's going to represent one term. These two large ones are 2x squareds. Okay, those are x squareds. These three here are going to be 3x's, and these here, 1, 2, 3, 4, 5, 6, 7, 8, are going to be a negative 8 because they are ones. Remember, we have the x squareds, the x's, and then the ones. Okay, these are shaded, so they are a negative. Now what we're going to do is we're going to put this all together, and we're going to put the sign in front of it. Think of it as that's a positive, and this is a positive. Now, we don't usually write positives unless we absolutely have to. But in this case here, we're going to write the positives in there, and we're going to put all these together. We're going to do positive 2x squared, positive 3x, and negative 8. And you'll notice it's 2x squared plus 3x minus 8. And we're going to ignore that front one there. We don't need a front one unless it's negative, so we don't need a front positive. But now those signs act as an adding and subtracting. All it means is that the term is positive or negative, okay? And then it's adding or subtracting. Remember that subtracting is the opposite of adding. So this is just adding negative 8. That's all it is, but we can write it out as minus 8 instead of plus negative 8. So we can definitely do that to save a little bit of work. So that's if there are three. You'll notice there are three terms to this polynomial there. We put those three together, three different types of block. This one here, you'll notice there's two different types of block. There is a dark x, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So that would be negative 9x, okay, because they're negative ones. And then we have 1, 2, 3, 4, 5. We have 5 positives, so it's going to be a positive 5. And this will be negative 9x, and we're going to add 5 to it. These are two separate terms, one term, two terms, and we put them together and it forms a polynomial. This polynomial has multiple terms that are together. Okay, so it's multiple terms. Now, to draw a set of algebra tiles based on a polynomial, okay, we're going to have to figure out what kind of polynomial it is and is it positive or negative. This first one here, negative 3x squared minus 2x, has two terms. It has this negative 3x, and I'm going to use a different color here, and it has a negative 2x, sorry, a negative 3x squared and a negative 2x. The negative 3x squared is a large box, and because they're not all nice squares, and because they're negative, we shade them in. So this is negative 3x squared, and that was supposed to be a little bit nicer. And we also have...
to the 11-12 office, please. Isaiah Cousins to the 11-12 office.
And there's an announcement, all right. And so we have a negative 2x. So the x is just a rectangle, and because it's negative, again, we shade that in. And so this diagram right here represents this polynomial expression. Okay. The next one here, x squared minus 7. We have, again, two terms. We have this x squared term, and we have, and I'm going to use, again, different colors for it. We have negative 7, okay? The x squared is going to be, again, a large square, and you'll notice, and this is just something to think about, there's no number in front of the x squared, and we're going to get into that later on, what's called a coefficient. We'll get into that later on. if there's no number, we just represent it as a 1. That means there's just one of them. This one here, though, there are 7 ones, so we have to draw 7 little ones. 5, 6, 7. And because they are negatives, we color them all in, and so they are shaded. Okay, so a positive and 7 negatives. The positive is an x squared. The 7 negatives are 1s. Okay, so they are a little bit smaller. Now the final one, we have 3 terms together here. We have, and again, we're going to try to do these all in different colors. We have a positive 2x squared. We have a negative 3x, and we have a plus 1. So the x squared, again, large squares. Okay, there are 2 of them, as mentioned by the number in front, and they are empty because they are positive. So there are 2 x squareds. We then have 3 negatives, negative x's, and these need to be shaded in. Again, those you could write them on their side as well. I like to put them up vertically, not horizontally. That's just my personal preference. And finally, we have 1 little one, and that one is not going to be shaded because it is a positive, and so we leave it open and we do not shade that one in. Okay. So that's how we can draw them out, and we can use them to, use them as a diagram for a polynomial. Now, the last little bit I want to go through is what happens if a positive and a negative tile are the same kind in a diagram. Well, if a positive and a negative tile of the same size are in a question or in a diagram, okay, the 2 will cancel out as one is negative and one is positive. Okay, a negative and a positive are going to cancel out. Now, only the common numbers. Okay, not all of them. Okay, only the common numbers. So once the common ones are canceled out, the remainder, okay, will be the term in the polynomial. So let's look at how that works here. Right here, you see we have a bunch of x's. Okay, there are 4 shaded ones and 2 yellow ones, or the unshaded. Okay, which means that we have 4 negatives and 2 positives. Well, these 2 positives cancel out 2 negatives. Now, it's a bit tough to see that, but they do cancel out, meaning that there's only these 2 remaining. So there's only 2 x's remaining, and they are negative. Okay, because these 2 cancel each other out. Okay, because one is positive, one is negative. On the other hand, the ones here, you'll notice we have 2 positives and 1 negative. So one of each is going to cancel out, and we're going to be left with just 1 positive left over. And so this would be our final answer right there, because the other ones are going to cancel out. Now, when you're drawing them out like this, just draw out whatever's given here. But if they are drawn out, you might be able to cancel some off and simplify those values. Complete questions 3 to 5, which deal with drawing out algebra tiles based on polynomials, as well as taking drawings and putting that back into a polynomial.